Hi dear students, welcome back to current electricity. So we are in equivalent resistors topic. Okay, so resistors series and parallel combination. In series and parallel combination we have seen potential. Just when we directly look some circuits, we will understand that this is series, this is parallel. From some end we will be able to solve and proceed. In certain topics, certain circuits, we won't be able to recognize it easily. So what we do, we will imagine a battery, we will put a potential at a point, and that between that node and other nodes, if there is no resistance, we will extend that voltage there. So we will find the nodes and easily we will be able to recognize these resistances are series, these are parallel. We will be able to solve the circuits easily. So today we are going to start Wheatstone's bridge. So regarding Wheatstone's bridge, in board exams, what is Wheatstone's bridge, and maybe its proof can be asked, okay, or otherwise problems also can be asked. In Neet and JEE, they will give some circuits. Immediately we won't be able to recognize this circuit is Wheatstone's bridge. We won't be able to recognize. But if we carefully analyze it, we will understand that this is Wheatstone's bridge. So here experience matters. If we do types of problem where Wheatstone's bridge is there and they are actually asking the equivalent resistance. Okay, so if we do problems like that, even during the exam, Neet or JEE or board also, we will be able to recognize this is Wheatstone's bridge. Immediately you will be able to reduce the circuit into comfortable form and we will be able to find the answer. So today we will see Wheatstone's bridge. Okay. Okay, so Wheatstone's bridge. Okay, and here there will be a resistance in the middle. So this could be connected to a battery, and this terminal also will be connected to a battery. So if this is R1, this is R2, R3, R4, R5. Okay, V is the potential difference between these two battery terminals. Clear? This is what is Wheatstone's bridge. But no current is flowing through this, we will remove all these are balanced condition. Okay, if the Wheatstone's bridge is balanced condition, if it is balanced, then no current will flow through this, that will come for balanced condition. Now this is actually Wheatstone's bridge. Clear? This is the real circuit of Wheatstone's bridge. All Wheatstone's bridge need not be R1 by R2, R3 by R4 and all. Okay, only for balanced condition R1 by R2, R3 by R4. Okay, now all our questions, most of our questions will be balanced only, even when they ask sorry equivalent resistance also. Clear? Now we will understand one thing. Suppose if I draw a resistance. Okay, if I draw a resistance, okay, if I imagine that this is connected to a battery, okay, if I connect this to a battery, now if we say this is V, V potential difference is there, or simply in our common language we say V voltage or 5 voltage, something like that. Suppose if this is 5 ohm and if this potential difference is 10 volt. Already I have mentioned this in your previous class. Again today I am telling this again because this is going to use here. This terminal can be 10 volt and this could be 0 volt. What is the meaning of this? When we say this battery supplies 10 volt voltage, it actually means that 10 voltage potential difference is possible here. 10 volt potential difference is what this battery is making. When we say the battery is of 10 volt, actually what that means, it is able to supply 10 volt potential difference, voltage difference across the circuit. Then only current will flow. If both are 10 volt, current will not flow. So this is actually able to give 10 voltage potential difference. I can write this in this way also. Correct? This is also fine. So when we do V is equal to IR, if I need to find the current through this circuit like V by R, if the voltage is 10, if we write like this is 10 volt and 0 volt, if it is like this, we will be writing 10 by 5. This is going to be 2 ampere. So 2 ampere current will be flowing through this. Correct or what? 2 ampere current will be flowing through this. 2 ampere, 2 ampere, 2 ampere. Right? Suppose if I write in this way, we will make this is 15 and this side 5 volt. Still 10 voltage potential difference is there. So in this circuit, if I'll draw another circuit. Okay. So this is going to be 5 ohm and this is 15 volt and 5 volt. Now you are now very clear about how to see the nodes. No resistance is there between two nodes. Those nodes are same. No resistance here. Okay, so I can say this is also 15 volt. This is also 15 volt. I can say this is also 15 volt. What about other side? If this is 5 volt, 5 volt, 5 volt, 5 volt. Now how can I calculate the current through this resistance? When I write here I is equal to V by R, this V is nothing but the potential difference. This is also potential difference, but what we are actually doing here, we are doing 10 minus 0 by 5. Directly we have written here 10 volt. For our easiness, we should do like that. We need not write like this. This is just for your understanding. I am writing like this. Okay. So this V is nothing but 15, this side 15 minus 5. So this is the potential difference between these two terminals. So if this terminal and this terminal both are at 15 volt, no current will flow. Current will flow from higher potential to lower potential. Just like a water flows from higher altitude to lower altitude, just like that current flows from higher potential to lower potential. So 15 minus 5 divided by 5. So 10 again, 10 by 5, this is going to be 2 ampere. Same current here, same current, 2 ampere, 2 ampere, 2 ampere. Why I am saying all this? See, when we need to find a current across a resistor, the voltage across the resistor, simply we say this 10 volt will be dropped here. The real meaning is this will be 0 volt, this will be 10 volt. That 10 volt will be taken here. Okay, the potential difference. So potential difference we need to consider. So if we get 2 points like a 15, 5, the current will be 15 minus 5 by 5. Okay, so current is voltage difference by resistance. Okay, note down all these basics and whatever I said, okay, whatever I said, you take it as running notes. Okay, important points you can note down. All this knowledge will help you while solving problems. Okay, clear? Right. Okay, now here for a balanced Wheatstone's bridge, is nothing but the current through R5 will be equal to 0. current through this will be 0. Okay, this is what the balanced condition. So I passing through will be 0. No current will pass through this. Clear? So if no current should pass through this, what is the condition? The potential across these 2 points must be same. If there is potential difference between these 2 points, definitely pakka there will be current flow. Okay, so the potential difference between these 2 points are same, then what will happen? No current will flow. This condition is what is called balanced Wheatstone's bridge. If that is the condition, we came to know that R1 by R2 is equal to R3 by R4. This by this will be equal to this by this. Okay, so this is a condition. Okay, this under this condition, this must be valid, then only this condition will happen. Okay, this is the balanced Wheatstone's bridge condition. Now we will see its proof also. Clear? Note it down. Okay, now we will see its proof. Okay, and assume we have connected a battery. Now I just put here V, this is 0. This is what is the conventional method, and that is easy to calculate also. For understanding purpose, we have 10, 15, 5, 5 minus 5 and all. That is for understanding purpose. It is here, it is not required. Okay, so suppose if this point is A, this point is B, this is X, this is Y. Now there is a resistor across this also. Okay, there is a resistor across this also. We'll put that R1, R2, R3, R4 and R5. Now what is the voltage across this V? 0, 0, 0, 0, 0. This is going to be 0. Clear? Now let's take the current I flows through this. Here it comes I1, here it goes I2. Now assume that the Wheatstone's bridge is balanced. This is balanced. Okay, this is balanced. If it is balanced, no current will flow through this. I is equal to 0. So I1, here also I1, I2, here also I2. Clear? This is the whole setup. Now when no current flows through this, the real reason is what? This node and this node X, Y are in same potential. So X, or we can say Vx is equal to Vy. So I can say like X is equal to Y. So what I am going to do, I put this node also X. Why we put? Just because no current flows through this and the potential difference between these 2 points is 0, we are putting X, here also X. Clear? Now we will write equations. Okay, now what is the current across this? What is the current across this point? I1. What is that? V minus X. If X is the voltage, okay, voltage at this point, this is the voltage, okay, Y is the voltage, okay, voltage at that point, potential at that point. Okay, so V minus X is equal to what? I1 into R1, equation 1. Same way, X minus 0, potential difference across this is equal to I1 into R3. I1 into R3 equation 2. Now this minus this, again V minus X is equal to I2 R2 equation 3. Same way, potential difference across these two terminals is X minus 0 is equal to I2 R4. Clear? Okay, now we will divide 1 by 3, 2 by 4 and all. Okay, so equation 1 divide by 3. Equation 1 divide by 3. V minus X by V minus X, we will be getting what? 1 is equal to I1 R1 divide by I2 R2. Clear? So what we get? I2 divided by I1 is equal to R1 divided by R2. We get like this. Okay, now 2 divided by 4. 2 divided by 4. X minus 0 by X minus 0 is equal to 1. So to I1 R3 divided by I2 R4. I2 R4. So what we are getting? Again I2 by I1 is equal to I2 by I1 is equal to R3 by R4. Clear? Now LHS are same. Left hand side is same. Left hand side of both are same. Left hand side of these two are same. So what we do? R1 divided by R2 is equal to R1 divided by R2 is equal to R3 divided by R4. Hence proved. Clear or what? So this is a proof that R1 by R2 is equal to R3 by R4 under the condition that no current flows through this. This will happen when the potential across these 2 points are same. Okay, copy this down. Okay, we will do some problems. We will do problems on this. Okay, if I give a circuit like this, and if I give same circuit, same shape also, and if I give 5 here, 10 here, 10 here, 20 here, I think no need to waste our time to do such simple problems. Okay, you will do yourself. Just if it is balanced, definitely you can put here 10 by 20, 5 by 10, both are same. One resistance may not be given. They may say like this is balanced. You will be able to find one resistance and all. Okay, we will do simple problems but different shapes. Circuit, just by seeing the circuit immediately we won't be able to say whether they are Wheatstone's bridge. Take question number 1. Two ohm, 4 ohm, 1 ohm, 2 ohm. This is 3 ohm. Terminal A, terminal B. Question is, what is the equivalent resistance across AB? Pause the screen, try yourself and verify the answer here. Copy this. Options: 1 ohm, 2 ohm, 3 ohm, 4 ohm. Okay. First we will see, this is almost like see, first tip is, if there are 4 or 5 resistances, no, minimum 5 resistances are there or 6 resistances are there, but just by looking we won't be able to say whether which is series and which is parallel. Okay, we won't be able to say. In Wheatstone's bridge, see, look here, if this resistance is meaningless and if this is R1 this is R2, this is R3 and this is R4. If it is connected like this, then these both are series. These both are series. Then they are parallel now. They are parallel. Very easy to find the equivalent resistance since we can remove this. This is the advantage of Wheatstone's bridge when they are balanced. When they are balanced. Note it down if you do not know. Okay. Now, immediately if we are not able to comment one circuit is series or parallel, whatever it may be, if there are 5 or 6 resistances, we should check whether they are Wheatstone's bridge, okay, and whether they are balanced. Now what we can see, this is R1, R2, R3, R4. This is a central resistance. We will be able to relate somehow. So check for this thing, whether they are parallel. 2 by 1 is equal to 4 by 2. R1, just consider this as R1. We can take this as R1, R2, R3, R4. Consider like that. 2 by 1 is equal to 4 by 2. This is also correct. They are equal. So no need to consider this 3 ohm. Now, if you want, you can redraw the circuit, but I am directly doing in this circuit. Okay, I just remove this. Now this is a simple circuit for me. Very simple circuit. Now R1 plus R2, 6 ohm, and R1 plus R3, 6 ohm, R2 plus R4, what is this, 2 plus 4, 6 ohm, R2 plus R4, 1 plus 2 is equal to 3 ohm. So if I consider this as Rx and this as Ry, then R equivalent, that is RAB, is nothing but directly if you want to find, you can write like this: 1 by RAB is equal to 1 by Rx plus 1 by Ry. So this is going to be 1 by 6 plus 1 by 3. So taking 6 as LCM, this is 1, this is going to be 2, this is going to be 3 by 6 is equal to 1 by 2. So RAB is going to be 2 ohm. Option B is the correct answer. Now suppose if you want to do directly, if they are parallel, this is 6 ohm and this is 3 ohm. So RAB is equal to R1 R2 by R1 plus R2. Directly you can do 6 into 3 by 6 plus 3. So 18 by 9 is equal to 2 ohm. Wherever if you get a combination 6 and 3 are in parallel, so many questions we have done where 6 and 3 comes in parallel and we are getting 2 ohm. So if 6 and 3 are parallel, no need to do, just directly write mark 2 ohm, save your time in your competitive exams. Note it down. Another question. Okay, you remember this is not the question. Just to show you, you remember this question. This A, this was A, we put A here. B, we put here B. Then between A and B, all the R's were in parallel and we took R by 3. You remember this? Now we will make small change in the circuit. Here we will put a resistance. Here also we will put a resistance. Now find the equivalent resistance, RAB. That is, find the equivalent resistance between terminal A and B. What is this? I did not write the question even once. Find the equivalent resistance between A and B, terminal A and B. Pause the screen and do yourself. All the resistances are R. Options: R by 2, R, 2R, 3R by 2. Okay, done. So verify the answer here. Now here we know the terminals. Suppose if we connect a battery like this is V, this is 0. So 0 will come here, 0 here. Here it is nothing but V. So what about this? This is not A or B. We will mark here X. Same way, what about this one? Nothing, not X, not A, not B. So we will mark here Y. Clear? So now what we will do, we will redraw this circuit and we will verify whether this is Wheatstone's bridge. So A, B, this will be V, this will be 0 volt, and this is X, this is Y. Just we will verify. So between A and X, this one we will draw like this. Okay. Between A and Y, another resistance. Okay, R. This also done. Between X and Y, there is another resistance R. Then X and B, between X and B, this is 0 volt, X and B. So X and B, this. So this is also done, this is also done. Then between Y and B, R. What is this? This is Wheatstone's bridge. So if it is Wheatstone's bridge, no current through this, I is equal to 0 here. So this is going to be R like this. This is R, this is R, this is R, this is R. And what about this? Terminal A, terminal A, terminal A, terminal B. So this is series, this is 2R. This is also series, this is also 2R. Now this is like what? It is coming like this. This is 2R, this is 2R, A, B. So 2R, two resistances in parallel, or n resistances in parallel, if they are same, we can say this is R by N. Okay, n resistances if we connect in parallel, if this is R, this is N, this is also R, 1, 2, 3, N, then this is R equivalent is what? R by N. So this is nothing but RAB is 2R, 1, 2 divided by 2. So cancel, R is the correct answer. Direct method, if you are writing for board exam, you can do like this: 1 by 2R plus 1 by 2R. Okay, so this is 2R divided by 2, 1 by RAB. So RAB is going to be R itself. Okay, direct method 1 by RB is equal to 1 by R plus 1 by R, 1 by 2R plus 1 by 2R. So taking the LCM 2R, 1 plus 1 2, and RAB is equal to R. Direct method. Okay, note it down. Okay, so 5 resistances or 6 resistances if you see, okay, directly just by looking directly we are not getting any indication whether they are series or parallel. Then check for Wheatstone's bridge. Okay, most of the time that will be Wheatstone's bridge. So we will take another question. Terminal A, okay, what is the equivalent resistance between terminal A and B? Options: R by 2, R, 2R, then 4R. Okay, pause the screen and try yourself. Pause the screen and try yourself, then verify the answer here. Okay. Okay, so what we will do, we'll check whether it is Wheatstone's bridge. So here this is actually A and this is B, till this is B. This is not A because a resistance is coming in between. This is also A. Here this is how. So this terminal we don't have any name, this terminal we don't have any name. We'll put X, this is Y. After that we will just draw like a Wheatstone's bridge and verify whether it is coming as Wheatstone's bridge. Okay, so this is A, this is X, this is B, and this is what? Y. Just like if we connect a battery, how it comes, that's how. Okay, A, X, B, Y. Okay, so between A and Y, a resistance R, A and Y, a resistance R. Okay, done. Then between A and X, another resistance R. Between A and X, another resistance R. That is also done. Between X and Y, one resistance R. Okay, this is also R, this is also R. So this is also done. Between Y and B, one resistance R. Done. Then between X and B, one resistance. Between X and B, one resistance. Between, what about this? This is Y. Yeah. Actually, this resistance is Y. Okay, this resistance is this X and Y. Then another extra resistance is here, this one, between A and B. So this is like either we can draw like this without touching, we'll put it here outside. This is also R. So this is how this circuit becomes. Whether this is Wheatstone's bridge, yeah, R by R is equal to R by R. Okay, so this comes like, so there won't be any current through this circuit. No current. I is equal to 0 here. I is equal to 0 here. So we will redraw. Now if you are really good in, means if you have done enough practice, then simply we can say R plus R 2R. This is 2R. no circuit here. This is also 2R, this is also R, right? So 2R parallel, what? R by N concept, N equal resistances connected in parallel, what will be the result? R by N. So here 2R, again 2R is connected in, if same resistances are connected in parallel, two resistance means that will become R by 2. Here 2R by 2. So the combination of this will be R. 2R is nothing but 2R by 2. So this is going to be R. Then R and R again parallel. So this is nothing but R by 2. So directly we will be able to say, if you, without doing anything, we will be able to say, once if you redraw like this, you will be able to comment the answer. But I will, this is 1, this is 2, this is 3. I will redraw this. This is R, this is R. Okay. Okay, so this is how the circuit will be: R, R and R. This is A, this is B. Okay, so 1 by RAB is equal to, this is what is actually, this is 2R, this is 2R, this is R. So 1 by 2R plus 1 by 2R plus 1 by R. Okay, so you can just solve this, okay, taking LCM, and you will be able to solve this and find RAB. You will be getting the same answer, R by 2. Note it down. Okay, clear? Clear or what? So sorry. Okay, so do it yourself. Okay, wherever you get circuits, try to do yourself and develop problem solving skills, circuit solving skills. Okay, I will give you another question. Okay, see this. Okay, what is the equivalent resistance between the terminal P and Q? Okay, options are there. Pause the screen and do it yourself. Okay, take the options also. Okay, right. What is the equivalent resistance between P and Q? So how to solve this question? So this they have asked in IIT mains 2002. Okay, they have asked in JEE, IIT JEE mains they have asked in this question. Okay, so how to solve this one? Now see, pause the screen, do it yourself, then verify the answer. Okay, see, now here, is there any way to solve this circuit? There is another way called symmetric circuit solving, that we will see in another session. Different ways are there, but we will see here Wheatstone's bridge method also. Okay, Wheatstone's bridge method, when you want to solve, see, just consider the upper part, so just like this one, if we compare these two, this is nothing but 2r by r is equal to 2r by r. So if this is r1, if this is r2, if this is r3, and if this is r4, consider like that. Okay, just like in our Wheatstone's bridge, if they are r1, r3, this is r2, and if this is r4, then see, r1, r2, r3, r4. This is balanced. When this is balanced, what I can do? I can remove this one. Okay, that headache is over. Okay, now this is clearly visible. Now see the second part, this one. Okay, so here I can take like r by 2r is equal to r by 2r. This is also like what? r1 divided by r2. This is r3 divided by r4 in our Wheatstone's bridge. r1, r2, r3, r4, balanced. This is also what? Balanced. So what I can do? I can remove this one over. Now this is easy, na? All these are in parallel. Okay, so what generally we do is 2r and 2r and series. So this is what? 4r. This is 4r. This is 4r, and this is 2r, and this is again 4r. So note this down, not this. Okay, so what is directly, if you want to do, we can do like that. 1 by rpq is equal to 1 by 4r plus 1 by 4r plus 1 by 2r. Likewise, we can solve this. Okay, or otherwise, by using this you can solve, and you will be able to do rpq. Easy method is what? 4r and 4r are parallel. 4r and 4r are in parallel. This is nothing but, so 2r. This 2r is in parallel with small 2r. Okay, so rpq is equal to 2r into 2r divided by 2r plus 2r. r1, r2 divided by r1 plus r2. Clear or what? Okay, so this is nothing but this is equal to 4rr divided by, what is this? 2 we will take outside, r plus r. So this and this will be cancelled off. We will be getting 2rr divided by r plus r. Which option? Option D. Okay, asked in JEE Mains. This is a decent question. Take this question. This is a circuit. Okay, 4 options are there. First option is no current flows through branch PQ. Another option is I1 is, that is this current is 3 ampere. Third option is potential at S is less than at Q. Potential at S is less than at Q. Next question is I2 is equal to 2 ampere. I2 is equal to 2 ampere. Pause the screen and try to do. So how to approach this? How to find this, sir? This is the question. See, the speciality is this is 2012 IIT Advanced. This question asked in IIT Advanced 2012. So, but whoever it may be, this question you must try to solve. Okay. So, this question is of the category more than one correct. More than one correct. More than one correct. So, this is 2. Okay. More than one correct means there is a category in JEE Advanced, IIT JEE Advanced, that is more than one option correct answer will be there. More than one correct options. Like generally in Neet as well as JEE means only one option will be correct. But in JEE Advanced there are some questions where not only one option, there could be 2 or 3 or many options can be correct. Okay, marks will be like that. Okay, so how to do this? First we will check first option. No current flows through the branch PQ. No current flows through the branch PQ. Let's verify. So what is this actually? Okay, this is Wheatstone's bridge or what? So suppose if we take this as R1, this as R2, this as R3 and this as R4, just see R1 by R2 is equal to R3 by R4. See, when I solve the problem, I am trying to write the steps for your understanding. Once if you are handy with the circuits, no need to write all these steps. Fatafat verify this, remove this thing from there. Likewise you should do. Okay, so 2 by 4 is equal to 2 by 4. 2 by 4 is equal to 2 by 4. So what we are doing, this will not have any current. This will not have any current. So option A is correct. This is correct. I1 is equal to 3 ampere. This one, we will do that because we need to we can reduce this circuit. That is easy also. Option C is potential at S is less than that at Q. So first thing what we will do, we will remove this circuit. Same way we will check this also. So if we say this is R1, this is R2. Okay, I will use another ink. Okay, this one just for better understanding. R1, if this is R2 and this is R3, this is R4. Correct now? Okay, 2 by R1 by R2 is equal to R3 by R4. Can I take 2 by 4 is equal to again 2 by 4. So no current will flow through this. I can remove this. I can remove that branch. So if that is the case, we'll take like this. Clear? Now question is potential at S. Potential at S is less than that at Q. Okay. So shall I erase this? If please note it down. Okay. So what I can write is potential at S is less than that at Q. Potential at P is equal to potential at Q. And potential at S is equal to potential at T. This is the reason. Because of this reason, no current was there through these branches, through PQ and through ST. You agree? No current flows through PQ, no current flows through ST. Why? Because their potentials are same. That is the reason we took like this. Clear or what? No current flew through that just because of this condition. Now current is flowing like this. Current is flowing in this direction. Current is flowing in this direction. Why current is flowing in that direction? Why current is flowing in that direction? Current is flowing in that direction because current is flowing in this direction because potential at P is greater than potential at S. Potential at P is greater than potential at S. And we know potential at P is equal to potential at Q. Correct or what? So potential at S is less than potential at Q. So because of this reason, I can write VQ is greater than Vs. So option C is correct. Okay, just once again I am repeating, this branch we removed just because no current flows through that, because potential here and potential here are same. Current flows from higher potential to lower potential. So I write Vp is equal to Vq. We removed this branch just because potential at S and potential at T are same. Vs is equal to Vt. Current flows in that direction from P to Q. Why? Because potential at P must be greater than potential at S. Then only current will flow in this direction. Otherwise, current will flow in this direction, just like a height difference. So Vp is greater than Vs, and we know Vp is equal to Vq. So Vq will be greater than Vs. So this option will be correct. Note it down. This is just like we are solving 4 questions. Okay. So note it down. Okay. Now I remove all this. Okay. So what they are asking? I1 is equal to 3 ampere. So for finding I1, what we will do? We will find equivalent resistance. R equivalent is what? 2 plus 2 plus 2, 6. 4 plus 4 plus 4, 12. So here it is nothing but these are in series and these are in series and they are in parallel. They are in parallel. So what we will do, R equivalent is nothing but 6 into 12 divided by 6 plus 12. Clear or what? Easy, right? So this is equal to 6 into 12 divided by 18. So this toto cancel, this is 3 toto, this is going to be 4 ohm. Understood na? You have solved many circuits, now resistances. I hope these kind of immediate solutions will be easy to save time. So is it correct or what? 4 ohm. Now what we will do, we will find current I1. So current I1 is nothing but V by R equivalent. V is nothing but 12. This is going to be 4. Okay, cancel, we will be getting 3 ampere. So I1 is correct, 3 ampere. Option B is also correct. Note it down. Okay, now what? We need to find I2. Okay, I2. I2. Okay, we need to find I2. What is I2? Easy. So 12 is here. That 12 is parallel with this. That 12 is parallel with this. So between this terminal and that terminal, method number 1. Okay, method number 1. Between this terminal and this terminal, actually how much is there? 12 volt is there. Because here 12. Here this is going to be 0 volt na. This is 12. Potential difference is 12 volt. This is nothing but 12 volt and 0 volt. 12. Here 0 volt, 0 volt. Okay. So what is I2? I2 is going to be V by R equivalent across that. Okay. So this is equal to 12 divided by 2 plus 2 plus 2. 2 plus 2 plus 2. So this is going to be 12 by 6 is equal to 2 ampere. So option D is also correct. One method. Another method is current division rule. What is I1? I1 is nothing but 3 ampere. Already we found 3 ampere. So I2, to find I2, what we need to do? Main branch current 3 into opposite branch resistance 4 plus 4 plus 4 is 12 divided by this resistance plus this resistance. Current division rule we have studied. So 12 plus 6. So this is going to be 3 into 12 divided by 18. So this is going to be 6. This cancel, we get 2 ampere. So this is method number 2. See students, this is the third method. I2 is to I3 is equal to 1 by R2 is to 1 by R3. Just for our convenience, I have taken, since we have put this as I2, I have taken this combination as R2 and this combination as R3 and put this branch as I3 for our convenience. So this is equal to 1 by, the combination is 1 by 6 is to 1 by 12. Now multiply with the higher number, that is 12. So when I do this, I will be getting 12 by 6 is to 12 by 12. So I2 is to I3, I will be getting what? 2 is to 1. 2 is to 1. Now to find I2 is equal to, the ratio of I2 is 2. Divide by total 2 plus 1 3 into what is the main branch current that is coming, that is 3. So 3 will be cancelled off, we will be getting 2 ampere. So all these 3 methods, there are different methods to find current. Okay, whichever is the easy method, whatever strikes your mind, immediately apply that and get the answer. So in this chapter, application skill is very important. Okay, by solving circuits and all, once if you receive the circuit, you should be in a position to understand how to proceed. Okay students, hope you understood the class. If you feel confused, see the video again and again and make it ready. Okay, so keep revising, keep practicing, take same questions of same type questions, same model questions, and practice it and make it very fast for your fingers. Okay, thank you students, goodbye, good luck.